Triangle ABC is a triangle in which BAC is 30. Show that BC is the radius of the circle of triangle ABC. So we have to show basically that BC equal to radius. BC equal to radius. In other words, we need to show BC equal to radius is here OB and OC. We start with what is given to us. It's given to us is angle BAC is 30 degrees. Now angle BAC is the angle at the circle. So let's find what is the angle at the center. So we get with the same B points B and C, and now we move towards the center. Here from B and C, from C we move towards the center and we get this angle. Now if this is 30, if A is 30, we know the angle at the center has to be double, which will be 60. So this is the first step. We have angle BAC equal to 30, and that is given to us. And angle BAC is twice angle BAC is angle BOC. This is by theorem. Of course, you need to write the statement of the theorem. So angle BOC is twice. We know BAC is 30. It's twice 30. So 60 equal to angle BOC. This is one part. Now earlier we found that angle BOC is 60. So let's take up triangle BOC. In triangle BOC, we have angle OB equal to OC because they are the side OB equal to side OC because they are radius. So we have OB equal to OC, and this is radius of the circle. If sides are equal, the angles, opposite angles are equal. So these two angles, I will call them as X and X. So I have angle OBC equal to angle OCB. Let me mark the angles again. We have OBC equal to OCB. These two angles will be equal. Say equal to X. These are angles opposite equal sides. Now in the triangle we have three angles, and when you add up three angles you get 180. So you have X plus 60 equal to 180. 2x plus 60 equal to 180, and 2x equal to 120. You will get your x as 60. So the angles here now are 60. This is 60. So it becomes an equilateral triangle. I just continue here. Since therefore triangle OBC is equilateral triangle. And why equilateral? All angles are 60. In equilateral triangle, all sides are equal, which now I can say OB equal to OC equal to BC. So OB equal to OC equal to BC. And we have proved now that BC equal to OB equal to OC, so BC is the radius. Okay, now for this sum we need to find angle A, and we also have to find angle C. We start from 140. 140 is the central angle, is the angle at the center. So we go to the arc now. It is, so angle BOC is 140, angle at the center. Let's try and find out which is the angle at the circle. So we have B and D. From B and D we now go to the, we trace a line to the circle. So here we have a line and this is another line here, DA we join, we get angle A. Angle A will be half of 140, so angle A will be 70. So let's write this. So angle A equal to half of angle BOD. This again is a theorem which you need to write in detail, that the angle at the center is double the angle at the circle. So angle A equal to half of 140, which is 70. So one step done. Now if we know angle A, we found this angle A, that is BAD, is 70. And the next part of the sum, this is 140, angle BOC is 140, therefore a reflex will be, this reflex angle will be 360 minus 140, so we write that. So we have angle BOD equal to 140, so we have reflex angle BOD equal to 360 minus 140, so that will be 120. So this angle is 120. So this angle at the center. Let us see what is the angle at the circle. So we go back here. This angle will be half of 120. What I'm doing in this is this figure which we have done earlier. If this is a circle, if I know this angle, then I can find here the relation is x and 2x. This exactly is the same figure, so this angle will be now 60. So angle, this angle is angle BCD, and angle BCD will be half of angle reflex BOD. So that would be half of 120, which will be 60. That's the next step. Now for the last step, we already found this is 60. Here's a mistake. This is not, this is 220. When you subtract, you get 220, which means now this angle is wrong. This is 220, so it's 110. So this is 110. So here this angle is 110. Now we know here we have a linear pair. I'll put this angle as x. So I'll have angle 110 plus x 180. So x is 180 minus 110, and that is 70. So angle DCB equal to 70. In this sum, we need to find angle PQB. So this is PQB. We need to find this angle. To remind you, the property we are going to use is if I have a circle, and in the circle, if there is a diameter, this is the center, and the angle in a semicircle is 90. So this angle is 90. Now let's see which is the angle in the semicircle here. So we have AB is the diameter. So we write that AB diameter. And the angle in the semicircle will be APB. So here is it's a point on the circle. So APB will be, this angle is going to be 90. So we'll write angle APB equal to 90. Reason, angle in a semicircle. Now if you look very carefully, you can see a triangle where two angles are given, and the triangle is APB. Look at APB. We know angle B 42. We know this angle is 90. We need to find the third angle. So we take up now triangle APB, and one angle, two angle, three angle equal to 180. So it is 42, 90, and we need to find this angle A. So we put that angle as A, small a, equal to 180. So I've taken the triangle APB and I'm using angle sum property. So this is now 132 plus A equal to 180, and A is 180 minus 132, which is 48. So here I have angle A will be now 48. Now let us see which angles are in the same arc. Angle A and which other angle is in the same arc. So earlier we got this angle as 48, angle A was 48. Let's trace angle A. This is angle A. It is in the segment P and B. From P and B we can go yet to another point. See, from P I go, I can come to Q, and from B again I come to Q. So I get one more angle here. So these two angles will be equal because they're angles in the same arc. So which means now angle, this is angle PAB is equal to angle PQB. So we write that. So angle PAB is equal to angle PQB, angles in the same arc. So we have angle PAB equal to angle PQB equal to 48. So the answer here is 48. In this sum we need to find CBD. So where is CBD? We start from C. Here is C. And let's trace CBD. C, then we have to go to B. And from B we have to go to D. So we'll get CBD. We need to find this angle. So the angle given to us is 40. Let's trace the angle 40. So this is angle 40, and if you see angle 40 is ACD, and angle ACD will be equal to ACD. So I need to come down ACB actually. This angle ACB will be equal to, from A I go to D, and now from B I go to also D. So I get these angles in the same arc. So this also will be 40. So angle ACB will be equal to angle ADB, which is equal to 40, an angle in the same arc. Let me trace it. Here I did angle from A, I went to C. This was one angle. That was my ACB. And then I had my angle from same A and B, I went to D. So these two angles are angles in the same arc. That's one part of the sum. Now let's get on to the next part. So we just erase this. We know this angle was 40. We found this angle is 40. Now we can spot a triangle where three angles are given, and the triangle is PBD. So this is PBD. So in triangle PBD, we have two angles. We know this angle 40 that we have found, and this angle 120 which is given. So we will now go ahead and find the third angle. So in triangle PBD, we have three angles equal to 180. So that is 120 which was given to us, 40 plus angle B equal to 180. So 120 plus 40, 160, plus B equals 180. So B equals 180 minus 160, and B equals 20. And angle B is also CBD equal to 20. Now this is an interesting sum. So we are given as 135, we need to find x. Now just let's trace x up. So this is angle x. It is the angle at the circle. Now which is its corresponding angle at the center? So from B and C, from the same point B and C, now we go to the center. So here we go to the center, and now we get this angle. Now if this is x, you definitely agree the angle here will be 2x. Now see what I have done. This is a circle. Here is the diameter, and from this point, if this is x, and here we have the center here. If this angle is x, then we know this, the central angle will be here at this place. This will be its central angle. So if I take this as x, this will be 2x. So I write angle CB, my marker is D, so I get CDB, CDB equal to x. I'm referring to angle CDB. This angle is 2x. Therefore, the central angle, that is angle COB, will be 2x by theorem. The angle COB will be 2x. Next part, we'll take a linear pair. Here we see we have a linear pair, that is 135 plus 2x. See, this is 135 plus 2x equal to 180. So 2x is 180 minus 135. So 2x equal to 45. So x is 45 by 2. So x is 22.5 degrees. Here we need to find x. Here we use the same property first. Angle in a semicircle is 90. So let's mark the diameter. For a semicircle, you first require diameter. This is diameter. AB is diameter. And let's mark the angle in the semicircle. So we have if we have a diameter, we have a semicircle. So this will be the angle at the semicircle. So this angle will be 90. This is how will you name this angle? This angle is ACB. ACB equal to 90. Now if we take up triangle ACB, the triangle ACB, let's darken it. You have ACB. In this triangle, we have three angles. We have 40, we have 90. So we can find now the third angle. So angle 1 plus angle 2 plus angle 3 equal to 180, which means 90, 40 plus C. So 130 plus C 180. C will be 180 minus 130, so C will be 50. So we got this angle as 50. Now for the next step, here we can see two angles in the same arc. If you trace angle X, this is angle X, it is in the segment of BC, and from B and C, if you now go from C, you trace up, and from B again you trace up, you come to this angle A. So, and we know angle A was 50. So X also will be 50. Both these angles will be equal. So let's write that. So we have angle A equal to angle D, angle in the same arc. So we have X equal to 50. Here again we've got to find angle X. So we know this is 120. If angle AOC is 120, we can now find the reflex angle. This reflex angle will be 360 minus 120. So you write that first. So we write angle AOC equal to 120. Therefore, reflex angle AOC equal to 360 minus 120, which is now 240. Now we know this angle is 240. If reflex AOC is 240, we can now find angle ABC. This angle ABC will be half of 240, and that will be 120. So angle ABC is half of a reflex AOC, which is half of 240. So angle ABC is 120. Then we do linear pair. Here 120 plus X is linear pair. So 120 plus X equal to 180. And X will be 180 minus 120. X will be 60. Just to remind you here, what property have I used? This is a circle. If I know this angle, this central angle, its angle at the circle will be behind it, will be here. So if this is now 240, this will be half of it, will be 120. Now in this we need to find X. So we start with linear pair. Here is a linear pair. I will put this angle as Y. So we know Y plus 65 equal to 180, linear pair. So Y equal to 180 minus 65. So Y equal to 115. So we got this angle as 115. Now back again to the same property here. If we have this angle, if we know this angle, we can find this, and the relation is if this is X, this becomes 2X. So this is 115. The central angle will be AOC. So here your X will be 2 times of 115. It will be 2X, so that it will be 230. So in the next step, we could say we have taken here as 115, which we already found out. So angle ABC, which was Y, is 115. And when we want to find out angle AOC, reflex angle AOC, here this angle AOC reflex. It will be 2 times of 115, and that is 230. So this angle will now be 230. Now for this sum, we know this angle is 60. Let's find its linear pair. So to find its linear pair, you have 60 plus this. We'll put this angle as a y. So 60 plus y is 180 linear pair. So y is 120. So I write here 120. Now for the next part, when I take up the triangle, OCA, that is OCA. Let's trace the triangle OCA. We have two sides are equal. OC equal to OA, they are radii. So I do OC equal to OA, the radii. And if two sides are equal, that means two angles also will be equal. This we have taken as 120 by linear pair. So two angles will be equal. Which two angles will be equal? The base angles. So if this is x, we'll have angle C will also be x. So I'll write angle A equal to angle C equal to x. Angles opposite equal sides. Are equal. So now in the triangle we have three angles, and when you add up three angles you get 120, angle x, and then we get 180, not 120, it's 180. Then you go ahead and find out x. 2x plus 120 equals to 180. 2x is 180 minus 120. 2x is 60, so x will be 30. Now for this sum, let us start with angle 40. Let us see which other angles is in the same arc. So for that, first you trace 40. Your 40 is A, B, C. Trace your angles. You use colors for this. Now when you come from A to D, now you trace back from A. From AC you can trace this to C, and from D there's yet another line, and this is C here. These two angles will be equal because the angles in the same arc. So here too you will write 40. So this is the first step. Angle ABD equal to angle ACD will be equal to 40. Angles in the same arc. This is one part of the sum. Now for the second part, we already have found this angle as 40. Now if you look up at the triangle PBC, you got to spot a triangle where two angles are given, and that is PDC. In triangle PDC, it has got three angles, will be equal to 180. Let's take out the three angles. One is 40, then one is 110, and one is x. So 150 plus x equal to 180. So x is 180 minus 150. So x is 30. Now for this sum, let's first find out which is the angle in the same arc. So we start with 35. Look at 35. Let's trace 35. This is 35. So the segment is now BC. From B and C we can draw yet another line. See, from B we can go up to D, and from the same point C you go up to D. You get this So here 35, this also will be 35 angles in the same arc. So let's write that out. So angle BAC, now where is angle BAC? BAC is this BAC is equal to angle BDC, angle BDC, which is 35 angles in the same arc. So this is the first part. Now for the second part, we erase this up. If you see, there would be a triangle where two angles are already given, CBD, and in CBD this angle of course is 65, angle B is 65. This angle D, we have just found out as 35. So if you take up the triangle CDB, and in this triangle CDB, triangle DCB, you have three angles equal to 180. So we have 35, 65 and x equal to 180. So 100 plus x 180, so x will be 80. So the answer is x equal to 80. Now this is an interesting sum. It involves two circles, but the properties remain exactly the same. In the first one, what I'm going to do is, here I have the circle, here I have angle 130. I will find the angle at this angle at the center. The angle at the circle will be half of 130. So that's what I'm going to do first. So here angle AOB is 130. That's the angle at the center. So angle at the circle will be ACB. So angle ACB will be half of angle AOB. So let's write that out. So we have angle AOB equal to 130. Therefore angle ACB will be half of angle AOB, and angle ACB is half of 130, and that is 65. So we've got this angle as 65. The next step, I'm going to do a linear pair. 65 plus say angle Y equal to 180. So earlier I got this angle as 65. I'm going to name this angle as Y here, and this is a linear pair. So I'm going to write 65 plus Y is 180. So Y equal to 115. So this is my second step. I got angle Y is 115. Now for my third step, now this angle we just found out is 115. Angle BDC is 115. Now this is the angle at the center. Let us find out the angle at the circle. So we have B and D here. From B and D we go to the center now, because we have to find the angle at the center, and we get this angle. So this 115, this angle will be double of 115, so that will be 230. So again, I just write that. We knew angle BCD is 115, which is BCD here. BCD is 115. Therefore, we found then angle BOD, double of it. So reflex angle BOD equal to twice angle BCD. That is twice 115, that is 230. Now we need to find x. Now what's the relationship between 230 and x? Here we have a complete circle, which means 230 plus x equal to 360. So x is 360 minus 230, and x will be equal to 130. 130. So x is 130.